Hello friends, how are you doing? In this video we are going to calculate effective mass of electron and as well as effective mass of holes. So for that we only need one file, which is called the AGR file, in which you have your band structure. So this is my band structure. So I'll be using this to calculate effective mass of electron as well as effective mass of holes. So basically the concept is we're gonna take a small parabola here in the conduction band and as well as a small parabola here in the valence band, and then we're gonna apply curve fitting to it and solve the formula and get our results. So what are these formulas? So basically I have made these notes. If you want them, you can just ask me in the comments. So theoretical concept is this, that there are total forces, one is internal forces, one is external forces, and then the mass is converted to effective mass. So this is the definition of effective mass, like h bar square and the second derivative of energy over the wave vector. So basically what I'm doing is we are applying curve fitting formula and we are solving this second derivative to simpler terms, like this is called curve fitting approach. So this is the energy a0k square plus a1k plus a2. So I'm gonna take the second derivative of the energy and it will reduces this equation to 2a, and then our main equation becomes h bar square divided by 2a, and after some dimension analysis it would become h bar square over 2 multiply 1.6 multiply 10 power minus 39. So our equation becomes 3.445 multiply 10 to the power minus 30 over a naught, and the units are in kg because we measure the mass of effective mass of electron and effective mass of holes in kg. So now the only thing we need is a naught. And how can we calculate a naught? We are gonna jump to the AGR file, and in this file we're gonna select two curves and we're gonna delete all the other curves so it becomes neat, and we're gonna choose some points here and some points here, and we're gonna apply this formula here, this formula. Yes, and when we apply this formula in XM Grace, it will give us the value of a0, a1 and a2, and we're gonna use use that a0 value into this formula, and it will give us the effective mass of holes and as well as effective mass of electron. If we take this parabola, it will give us effective mass of electrons, and if we take this formula, this parabola, it will give us effective mass of holes. So I'm gonna just make some changes here. So I have to remember these strings. For example, it's S683200, and now I can see that I'm calculating these effective masses on gamma point because it's a direct band gap. So I can see clearly that this is the parabola corresponding to this parabola. So this number is 653200. So I have only these two files, so I'm gonna select all these files and exclude these files and delete them all. So now we are good to go. We have these two lines in the band structure, and now we're gonna reduce this whole graph into just a small parabola so that we could apply the curve fitting formula. So I'm gonna just select it and I'm gonna choose my points here. For example, I know this material has a band gap of 0.30 because I don't know the value of gamma. I know the value of y-axis which corresponds to the band gap. So I'm gonna just select it and open it up and convert it to xy, apply it, and now I have to go to its band gap. Now I can clearly see the band gap is reducing, and from this point on, yeah, this is 0.30, and from there it's start increasing again. So this is my point 51, and this is this point, and corresponding to this point is 0.444. So I came to know the value of the gamma point, which is 0.44, and when I calculate the effective mass of holes, I'm gonna look for this value in the x-axis, and the corresponding will give me the 0 if I'm correct. So I'm gonna choose just 5 points above, 1 2 3 4 and 5. Similarly 5 points below. So I'm gonna just delete all the other values, 1 2 3 4 5. So I have to delete all the 45 values above. You can convert this into Excel file and apply curve fitting formula there, but I find this I used to calculate this curve fitting in the XM Grace. We are almost there. So I'm gonna go and edit and delete the selected rows. Yep. Yeah, I wanna delete them all. So now I have 1 2 3 4 5 points above, and now I have to carefully select 5 points below. 1 2 3 4 5. Yep. And I'm gonna start from 11, and now I'm gonna delete all the rows below so that it reduces to only 11 points, so that I could apply my formula easily. So in this video I'm gonna just calculate the effective mass for one thing, for electron, and the process is same for the hole. You can just skip this part and move to that part where I have the clean parabola. Yeah, we are almost there. So just delete these rows. Alright, here we have the smooth parabola here. So what now we're gonna do is we have to go in data, and we have to go in transformation, and here we have to go in non-linear curve fitting, and here we have to select this line which has 13 points, and we have to apply that formula here. So I'm gonna just always keep it on top and open this up. Yeah, so I have to minimize it. Yeah, okay. I can do just to keep this on top. Yeah, so basically the formula is a naught multiply by, call it x square, and plus then a1, then call it k as x, and then plus then a2, and then select the parameters. We have three here. A1 we have a naught, a1, a2, so it's 3, and just apply here. Maybe there is a syntax error here. Yeah, here there is a syntax error here. Yep. Yeah, now we have a naught, which we are required to calculate. So this is the value of a naught, which is 66.88. and now you have to put that value into your formula here, which is this formula. And when you divide this 3.445 multiplied by 10 to the power minus 30 with this a naught, you will get your effective mass. And in my case, I was calculating the effective mass of electrons, so I will get the effective mass of electron. And things you can do with effective mass of electron, you can divide it by mass of electron and calculate the ratio of effective mass of electron divided by the mass of electron. And also you can calculate you can do this for the holes, as well as you can calculate the ratio of effective mass of electron divided by effective mass of holes. So in papers you can find these results like this. I have one paper here. Let me go in my directory. Yep. This is the a paper here. In this paper they have calculated the effective mass of electron and holes, and they gave this result: the ratio of effective mass of electron divided by effective mass the mass of electron, the m naught, and the effective mass of holes divided by m mass of the electron. So you can calculate these, as well as you can calculate the effective mass of electron divided by effective mass of hole. So it will give you good insight about your materials carrier transport properties. So I think this video will be helpful. So you have to just practice it, and you're good to go. So I think this is enough for this video. See you in the next video. Till then, take care. Peace.